Let's continue to talk about linear algebra. Traditionally, the introduction of linear spaces express the idea of assigning some algebraic structures to the sets. In fact, a linear space is a very complex algebraic structure, and its construction requires the concept of monoids, Abel groups, rings, fields, and modules. So it's very difficult for beginners. We start from another way of thinking. That is about the Hom factor. The Hom factor leverages the intrinsic structure of the field to convert a set into a linear space. So this is not easy to understand. So we start from the set, the theory of set. Last time we talked about category. Now we have our first category. That is the category of sets. So last time we have explained the definition of a category with the collection of objects and the arrows, the morphisms, the associability, and identity. We take example like video cables and matrix multiplication. But in mathematics, the most studied category is the category of sets. Now we begin with functions. A function is an arrow. Let it be f. The arrow maps from a set x to a set y. This is mapped from set to set. So we write x, y is, they are the objects of the set. Set is the category of sets. And it also maps the elements from an element in set X to an element in set Y. Notice here's a small bar in the arrow. This arrow without bar is equivalent to the LaTeX 2, and the arrow with a bar maps 2. So we distinguish between the map from set to set and from element to element. They are elements. They are sets. Sometimes we also write it compactly like f x 2 y and double comma x1 maps to f x1. Okay, so it's indeed a category because xy are objects and functions f, and we can have multiple arrows from x to y, like f1, f2, f3. And we can also make composition like G1, G2, G3. We can composite G1 circles F2. This this composition of functions is indeed a function from x to z. And we also have identities like idx, idz, idy. So what is idx? Idx, if we write it down, from x to x, we map any x as elements into idx that equals to x itself. So it satisfies the definition of category. So we get the category of sets.